Assalamualaikum. Today we will discuss subtopic 4.3 Isomerism. At the end of the lesson, students should be able to define isomerism, constitutional isomerism and stereoisomerism, identify and construct constitutional isomerism, chain isomer, positional isomer, functional group isomer, describe cis-strand isomerism due to restricted rotation above C double bond C, C single bond C in cyclic compound. Identify cis-strand isomerism of a given structural formula. Define chirality center and enantiomers. Identify chirality center in a molecule. Determine optical activity of a compound. Draw a pair of enantiomers using 3D formula. Organic compounds that have the same molecular formula but different arrangement of atoms are known as isomer. The existence of two or more organic compounds with the same molecular formula but different arrangement of atom is called isomerism. There are two types of isomerism: structural or constitutional isomerism, stereoisomerism. Molecules that have the same molecular formula but have different structural formula are called constitutional isomer. Constitutional isomerism is formally known as structural isomerism. Constitutional isomerism can be subdivided into three different categories which describe more precisely how the isomer differ from one another: chain isomerism, positional isomerism, functional group isomerism. Chain isomer are those which differ in the structure of their carbon chain, that is, they differ in the length of their straight chain or branch. Question: how many structural isomer does pentane C5H12 have? Pentane has three chain isomer. First, longest carbon skeleton 5C. Second, 4C carbon backbone. So you will get one branch. Third, 3C carbon backbone. You will get two branch. Example 1. The chain isomer are alkene with the formula C5H10. Question 1. Draw structural isomers of compounds with the molecular formula C6H14. Strategy: first, draw all possible skeletal structures without the H atoms, beginning with the longest possible structure. Then, each C in the answer would have one H drawn near it with a line connecting the C and the H. 5-chain isomers for hexane C6H14. Positional isomers have the same carbon skeleton and belong to the same homologous series but differ in the position of the functional group. In general, positional isomers have similar chemical properties because they have the same functional group. However, they have different physical properties. Example, alcohol with the molecular formula C3H8O. Other examples of positional isomers are chloroalkane with the molecular formula C3H7Cl, alkenes with the molecular formula C4H8, alcohol with molecular formula C6H14O. Functional group isomerism is shown by isomers which have the same molecular formula but contains different functional group. In other words, these isomers have the same molecular formula but belongs to different homologous series. This type of isomerism is exhibited by many organic compounds. Functional groups isomer have different chemical and physical properties. Some examples of functional group isomers are given in the table below. The following are examples of functional group isomerism. Example 1, C4H10O. Example 2, C5H10O. Example 3, C6H12. Stereoisomers are isomers with the same structural formula but they have different spatial arrangement of their atoms. Stereoisomerism, the existence of chemical compounds which have their atoms connected in same order but differ in arrangement in space. Stereoisomerism can be divided into two categories. First, optical isomerism. Second, cis-trans isomerism. Cis-trans isomerism is also known as geometrical isomerism. Cis-trans isomerism occur in compound in which free rotation is prevented by the presence of a carbon-carbon double bond or a cyclic structure. Cis-trans isomers have the same structural formula, that is, the sequence in which the atom or group in the molecule are bonded are the same. They differ only in how the atom or groups are oriented in space. For example, 2-butene exists as two cis-trans isomers. In cis-2-butene, the two methyl groups are on the same side of the double bond, while in the trans isomer, the two methyl groups are on opposite side of the double bond. Both the cis and trans isomer have the same functional group and thus they have the same chemical properties. Rotation of the carbon-carbon bond is prevented not only by the presence of a double bond but also by the presence of a ring structure. Example of cyclic compound which shown cis-trans isomerism is 1,2-dimethyl cyclopentane. Exercise 2. Draw the structure of cis-trans isomer of 1,2-cyclobutanediol. Enantiomers is stereoisomers that non-superimposable mirror image of one another. It occurs only with compounds whose molecules are chiral molecules. Chirality center is sp3 hybridized carbon bonded to four different atoms or group. It also known as chiral carbon, asymmetric center, or stereogenic center. Is often labeled as asterisk. Enantiomers have the same structural formula but different spatial arrangement of the atom. They are mirror image of each other, but because of the asymmetry of their molecules, the two mirror image cannot be superimposed on each other. How to show the 3D structure on paper? The wedge line represents the covalent bond coming out of the plane of the paper. The wedge dash represents the bond behind the plane of the paper. The solid line represents the bond lying in the plane of the paper. Label asterisk at the chiral carbon in each of the following molecules. Answer A. The molecule has one chiral carbon atom. B. The molecule has two chiral carbon atoms. C. No chirality center. D. No chirality center. Example 5. Label asterisk at the chiral carbon in each of the following molecules. Answer A. No chiral carbon. B. The molecule has three chiral carbon atoms. C. The molecule has one chiral carbon atom. Optical activity is the ability of certain crystal or solution of certain substance to rotate the plane of plane polarized light. Such substances are said to be optically active. Polarimeter is used to determine the optical activity of a compound. The requirement for optical active compounds: first, molecule contains a chirality center or stereogenic center or asymmetric carbon. Second, molecule is not superimposable with its mirror image.